the preview video for lesson 5.2, special right triangles. You should have this calendar ready. Taking a look here, we are right at this point in class. We've talked about the Pythagorean Theorem and radicals, therefore this is your homework. You need to finish lesson 5.1 if you have not done so, and turn that along with this preview note. Taking a look. You only use this page if you are absent or turning things in late. Make sure you use this packet effectively. When I say pause and do your own work, actually pause and do your own work, and then restart and check for your understanding. Always both watch and listen. Do not just copy. When you're finished, take 2 minutes and verbally review the content of the lesson. Talk yourself through the main concepts. That is absolutely critical. That will solidify the information. Remember to get your parents and guardians to sign off. If you do not like watching videos, you are welcome to come in person and do this with me in person during lunch, after school, or optional second if you have it, as long as it is before the due date. Taking a look here, we're doing lesson 5.2, special right triangles. Make sure you give me the location. If you're watching the video, the date and time, and don't forget a parent, guardian, sign off. In class, we studied the Pythagorean Theorem, and we use this when we have two sides and we need a third side. So you're going to label leg, the leg, and the hypo. Here's a leg, here's a leg, and here's the hypotenuse. I'd like you to write this out. We're going to do leg squared plus leg squared equals hypo squared. Now you guys might be familiar with it with a squared plus b squared equals c squared. You're welcome to use that, except some students get confused. What is a, b, and c? And honestly, it doesn't matter which one's a and b. That's why I prefer this descriptive version. And you will always, 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 always write out the equation. Now, we circle plug Chuck. Our first leg is going to be x, parentheses squared, plus our other leg is 3 squared equals our hypo, which is 6 squared. You want to write that down. Now we're going to solve for x. And we have here, we have x squared plus 3 times 3 is 9. 6 times 6 is 36. Our goal is to get x by itself. So we're going to minus 9 both sides. We have x squared equals 27. Now, really, 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 really important. The opposite of squaring is not dividing by 2. If you want to get rid of this 2, we do not divide by 2. What I just did was wrong. The opposite of squaring is square rooting. Please be very careful with that. The opposite of squaring is square rooting. So we have x equals square root of 27. Now, if it's not a perfect square, I expect you to factor and simplify. 27 is not perfect, so we're going to factor. 3 times 9, 3 times 3. We have a date, a pair of 3's. Therefore, they're going to come out. 3 on the outside. And then this 3 does not have a date, stays home. So your final answer is x equals 3 root 3. Okay, today we're going to focus again on right triangles, but something called special right triangles. Special right triangles. And by the time you're done with today's lesson, you're going to be familiar with these terms. Pythagorean Theorem, a 30, 60, 90 triangle, a 45, 45, 90 triangle, an isosceles right triangle, a special right triangle, and we're going to be talking about patterns today. Before we do anything, though, we need to review. It's very important that we review radicals. So I'm going to do this first row with you, and you try the second row on your own. Root 3 times root 3 technically is root 9. But that's perfect. So it becomes 3. So root 3 times root 3 becomes 3. Root 2 times root 2 technically is root 4, but that's perfect, so it becomes 2. I hope you're noticing a pattern here. Root 2 times root 2 is just 2. You should notice any radical times itself is just the number on the inside. So we're going to get rid of that middle step here at this last one. Root 5 times root 5 is just 5. Any radical times itself is just the number on the inside. I'd like you to try this row on your own. Pause the video, do the work, restart the video. Did you actually pause the video and do your own work? If not, go back, pause the video, do your own work, then restart. Alrighty, let's check this out. Ready? Root 2 times root 2 is 2. And then you go like this. 3 times 2 is 6. Root 3 times root 3 is just 3. So 4 times 3 is 12. Root 6 times root 6 is just 6. Then we do 5 times 6 is 30. Now we're going to talk about squaring and simplifying. 6 root 2 squared means this. We always expand exponents. Always expand your exponents. Always, always, always. That means we spell it out. So 6 root 2 squared, it means we're doing 6 root 2 times 6 root 2. Now we multiply our outies. 6 times 6 is 36. We multiply our innies. Root 2 times root 2 is 2. $36 times 2. You should be able to finish that one on your own without a calculator. Now, pause the video, do the U try, and restart. All right, let's check this out. 4 root 3 times 4 root 3, 4 root 3 squared looks like this. Now we do outies. 4 times 4 is 16. Innies. Root 3 times root 3 is just 3. 16 times 3, 48. 5 root 5 squared looks like this. 5 root 5 times 5 root 5. Always expand your exponents. Always expand your exponents. That means spell it out. Outies. 5 times 5 is 25. Innies. Root 5 times root 5 is just 5. 5 quarters, 125. Now we're going to fill in the blank. It reads like this. 5 root 2 times something is 10. Well, we know 5 times 2 is 10, so you have to ask yourself, what do we need to make this root 2 become just plain old 2. And what we need is another root 2. Because root 2 times root 2 is 2. And then we can go like this. 5 times 2 is 10. So that blank there is going to be root 2. 3 root 3 times what is 9? Well, we know 3 times 3 is 9. So we ask ourselves, what times root 3 would just give us 3? And that's going to be another root 3. Root 3 times root 3 is 3. And 3 times 3 is 9. Now this last one gets a little trickier here. We know we need to cancel that root 5 with another root 5. But root 5 times root 5 just gives us 5, and we're trying to get 30 there. So we ask ourselves, what times 30, what times 5 is 30? The answer is 6. And then we can go 6 times 5 is 30. So the blank here is 6 times 5. Ready? You do these blanks on your own. Pause the video, do the work, restart. Did you actually pause the video and do your own work, or are you just waiting to copy me down? Copying is not learning, students. If you're just copying this video and you're not actually thinking through the problem, you're not learning. So if you didn't do this on your own, pause the video, do your own work, take a wild guess if all else fails, and then restart. Okay, students, welcome back. What you should have here in this blank is just root 2, because root 2 times root 2 is 2, and then 3 times 2 is 6. And this blank is going to be 2 root 5. I'm not going to explain those. Hopefully you understand this by now. Now, we learned in last class, we talked about the Pythagorean Theorem. The most important thing is to understand when to use the Pythagorean Theorem. When you use the Pythagorean Theorem, you have two sides of a right triangle and you need the third side. Two sides of a right triangle and you need a third side. When you have two sides, need third side. Two sides, need third side. That's going to be the Pythagorean Theorem. So here we label our leg and a leg and our hypo. Always label. And here our leg is going to be x. So write the equation out. Leg squared plus leg squared equals hypo squared. But Miss Way, I know the equation. I don't want to write it down. Tough. You will always write down this equation every single time. And I prefer the descriptive equation, not a squared plus b squared equals c squared. Now we circle plug shut. Our first leg is x. So x squared plus the next leg is 6 squared equals hypo, which is 9 squared. Now we simplify. We have x squared equals 6 times 6 is 36. 9 times 9 is 81. You should know your perfect squares by heart. You should be doing this without a calculator. And a minus 36 both sides. 6 from 11 is 5. 3 from 7, we have 45. Now, the opposite of squaring is not dividing by 2. What I just did was, with the pink, was wrong. The opposite of squaring is square rooting. So x equals the square root of 45 Now that's not a perfect square, so you have to factor it out. It's going to be 5 times 9, and 3 and 3. If you have a pair, they're going to come out. And no pair stays home, has pizza. So our leg here is going to be 3 square root of 5. Again, when do you use the Pythagorean theorem? When you have 2 sides and you need a third side. You have 2 sides, you need a third side. Now there is an exception to this. If you have what's called a special right triangle, you only need one side, and you can find the other 2 sides using what's called pattern tables. So the most important question is, what's a special right triangle? Now, a special right triangle isn't one that's just pretty or something. It's specifically these 2 right triangles. Special right triangles is the isosceles right triangle, also known as the 45, 45, 90. Because remember, if you have 2 sides equal, you have 2 angles equal. So the 45, 45, 90 is also called the isosceles right triangle. Your other special right triangle is the 30, 60, 90 triangle. 30 degrees, 60 degrees, 90. For each of these, there's special patterns to the Pythagorean theorem. Therefore, we're going to be developing shortcuts, and you don't even have to use the Pythagorean theorem. You memorize the patterns and use them. Let me show you. We're going to solve for 2 45, 45, 90 triangles. Make note, the first thing, since you have 2 equal angles, you automatically have 2 equal sides. So here we have one leg is 4, the other leg is 4, and then our hypo is our x. So we're going to use the Pythagorean theorem. Leg squared plus leg squared equals hypo squared. Let's solve this together. 4 times 4 is 16, plus 4 times 4 is 16 again, equals x squared. We get 16 plus 16 is 32, equals x squared. The opposite of squaring is square rooting. So we have x equals the square root of 32. Since 32 isn't perfect, we must factor it. 2 times 16, 2 times 8, 2 times 4, 2 times 2. We're going to pull out our dates, and we have 2 pairs of 2's, so that's 2 times 2 on the outside, square root of 2, so bring this together, that's going to be 4 root 2. Watch very carefully, so our hypotenuse here equals 4 square root of 2. Over here, let's take a look. Here we have one leg is going to be 5 root 2. We have a hypo of 10. We're going to solve for the other leg. So it's x squared plus 5 root 2 squared equals 10 squared. This is x squared plus exponents. Always expand. 5 root 2 times 5 root 2 equals 10 times 10 is 100. This is x squared equals, that's 5 times 5 is 25 times Root 2 times root 2 is 2 equals 100. That's x squared equals 2/4 is 50. So we have x squared equals 50. Square root both sides. We have a date. The date is 5. Square root of 2. Which makes sense because we have two equal angles, we must have two equal sides, square root of 2. So notice the pattern here. We have 5 root 2, 5 root 2, 10. Now notice both of these are 45, 45 triangles. What I'd like you to do is, what kind of observations can you make about both of these? What kind of patterns can you spot? I'd like you to take about 30 seconds here, or a minute, and write down whatever observations you can make. You're going to do this completely on your own. I'm not going to fill that in spot for you. Come up with your own observations. I'm going to give you a minute to come up with your own observations about these two triangles. Write as many observations as you can. Okay. What you should have noticed, one, was that the legs are equal. That's the first thing. And the second thing you should have noticed is to go from a leg to a hypo, you simply times by root 2. So that is the two patterns you have here that you should be familiar with. In a 45, 45, 90 triangle, and this only works in a 45, 45, 90. 1, the legs will always be equal, because if you have two equal angles, you have two equal sides. 2, the hypo is whatever the leg is times the square root of 2. So the hypo is whatever the leg is times the square root of 2. Let me do a couple examples with you. And right here, first we're going to label our legs. We have a leg here. We have a leg here. And we have a hypo. So we know the first pattern is the legs are equal. Leg equals leg. So if this leg is 3, automatically this leg is 3. This only works for a 45, 45, 90. To get the hypo, draw a little arrow. To go from here to here, we simply times by root 2. And 3 times root 2 is simply 3 square root of 2. That's it. Ta-da! Yep, that's how hard that gets. Let's try another one. Let's see what we have here. Always start by labeling your sides. Here we have a leg. Here we have another leg. And and here we have a hypo. Now our pattern is the legs are equal, and the hypo is whatever the leg is times root 2. Wait a minute, Miss Way, there's no root 2 there. It's not that you artificially tack on a root 2. What it is circle the leg, draw an arrow, please, to a little times by root 2. You're timesing by root 2 to get to the hypo, so it reads like this. Something times root 2 gave us 10. That's what you're thinking of. That's why we practiced radicals at the beginning of the lesson. Something times root 2 is 10. We have to backtrack and figure this out. We know we need a root 2 there because root 2 times root 2 is 2, so at least we get rid of the radical. Now we have to add a 5 here because 5 times 2 is 10. So our legs is going to be 5 root 2, and this is 5 root 2. The legs are equal, and the legs times the square root of 2, so 5 root 2 times root 2 is 10. There's your check. So in this case, the x and y is 5 root 2 and 5 root 2. Ready? Pause the video, do this one on your own, and restart. All right, did you actually pause the video, or are you just waiting to copy from me? If you're waiting to copy, pause the video. Take a wild stab at it on your own, and then come back. All right, welcome back. So first, let's write our table out. Our 45, 45, 90 table looks like this. Leg, leg, hypo. We know the legs are equal, and the hypo is whatever the leg is times square root of 2. It's times root 2. Here we have the hypo, so we have to work backwards. So we go like this. Something times root 2 is 6. It reads like this. Something times square root of 2 gave us 6. So you had to backtrack there, and your answer should have been 3 root 2. So for both x and y, you're going to get 3 root 2 because the legs are equal. So once you solve for one, you already have the other. That's for a 45, 45, 90 triangle. That's the pattern. Now you have another one called a special right triangle, and that's called the 30, 60, 90. Notice 30 degrees, 60 degrees, 90 degrees. So we're going to start by labeling. Here we can't just say leg, leg. We have to say short leg. I'm going to write S leg for short leg. This is going to be L for long leg. Short leg, long leg, hypo. Go back and label. The short leg is always across from the 30 degrees. So short leg, long leg, hypo. Short leg, long leg, hypo. Okay, so here we have a 5. Here we have 5 root 3, and we're going to solve here. We're going to use the Pythagorean Theorem. So 5 squared plus 5 root 3 squared equals unknown squared. Let's solve this. This is 25. 5 root 3 times 5 root 3. I'm expanding it so you can see it here. 5 times 5 is 25. Root 3 times root 3 is 3. 3 times 25, 3/4, that's 75 equals x squared. So here we have x equals 10. let's try this one over here. We have an x, a 9, and a 6 root 3. So we're going to solve leg squared plus leg squared equals hypo squared. There's our short leg. That's our unknown. Our long leg is 9, and our hypo is 6 root 3. We're going to do x squared plus 81. 6 root 3 times 6 root 3 looks like this. Squared, 6 root 3 times 6 root 3. 6 times 6 is 36. Root 3 times root 3 is 3. So we're going to do 3 times 36. Oh my goodness, we're going to do double-digit multiplication by hand. Yes. That's going to be 18. I'm going to wait. Now we're going to minus 81 both sides. End up with x squared equals 27. We square root both sides. And that's x equals 3 root 3. So this x is going to be 3 root 3. Now, there is a pattern here for both. In fact, there's two patterns here. There's one pattern that says, what do you notice about the short leg to the hypo? Short leg to the hypo. Notice, short leg to hypo. 5, 10, 3 root 3, 6 root 3. There's the same pattern. Look at it very carefully. That's one pattern. And then the second pattern is, what do you notice about the short leg to the long leg? 5, 5 root 3, 3 root 3, 9. There's two patterns there. I'd like you to look. It's the same pattern for both the left and the right triangle. I'm going to give you a minute. Do it on your own. Make those two observations. Go. All right. This pattern, what I'm about to show you, only works for 30, 60, 90 triangles, nothing else. In a 30, 60, 90 triangle, everything starts with the short leg. So we start here with the short leg. So just write short leg. The short leg to the hypo, you simply times by 2. So the hypo is always 2 times the short leg. The long leg is the short leg times root 3. Again, this only works for a 45, 45, 90 triangle. Let me show you what I mean here. So you always want to start with the short leg. So, for example, here we have the short leg. So I'm going to write short leg. To go from the short leg to the hypo, we times by 2. And to go from the short leg to the long leg, we times by root 3. Draw those arrows with your shortcuts, please. Draw them exactly as I've drawn them, please. So here, if our short leg is 3, 3 times 2, our hypo has to be 6. And if our short leg is 3, our long leg times root 3 is simply going to be 3 root 3. Ta-da! You're done. Let's do a couple more examples. Okay, so right here we have, let's label short leg, long leg, hypo. Always start with your short leg. This is the short leg. So short leg. And the pattern is this. To go from the short leg to the hypo, we times by 2. And this way, to go from the short leg to the long leg, we times by root 3. Now I know that this is the short leg because that's 30 degrees and that's the smallest. Problem is we don't have the short leg, so you kind of have to backtrack here. Let's start with what we do have. We do have the long leg, so it reads like this. Something times root 3 gave us just a straight up 3. That's what you're thinking. Something times root 3 is 3. Something times root 3. Something times root 3 is 3. Hopefully you see this by now. Any radical times itself unlocks the radical. So our short leg here is simply going to be the square root of 3. And then when we times that by 2 to get the hypo, it's simply 2 times the square root of 3. Ta-da! You're done. Really, that's how hard that gets. Ready? I'd like you to use the 30, 60, 90 table. And try this last one on your own. Use this table to guide you. Do this on your own in the next minute. All right. Let's see how you did. This was the long leg. This was the short leg. And this was the hypo. And we know the short leg to the hypo we times by 2, and the short leg to the long leg we times by root 3. That's our pattern. Problem is we didn't have the short leg, but we do have the long leg, so it reads like this. Something times root 3 is 4 root 3. That's this right there. Something times root 3 is 4 root 3. And you ask yourself, what is that something? Something times root 3 is 4 root 3. The something is just straight up 4. So 4 goes here, and then we simply times by 2 to get the hypo, so our hypo is 8. Now what I recommend is you take 2 minutes of your own time and verbally summarize what you've learned and then visualize your solution to a single problem.